hello, wonderful students. Let's go take a look at 509. And for some reason, I think I keep saying 3. I don't know why, but haha, I didn't add this to the other one. Okay, since we're here and we're on this video, please remember that we don't have traditional lock dates as you would find in a lot of universities and a lot of schools, where once the due date is past a certain point, you can't turn stuff in anymore. Here, which I think is quite nice, you can go in and do all of your content that is computer graded. I think that should always be true of all courses, including online courses. If the computer grades it, why in the world should the teacher lock it? If you want to choose to wait till the 44th day with 5 hours remaining, that's your choice. It's part of this world and life. And I was not much of a procrastinator. I am kind of right now in certain tasks, but it's not really procrastination. It's being busy and prioritizing what I think is important. Anyway, what I'm trying to say is that's very cool. But this is letting you know that after that point, it's a lot harder, if not impossible, to open up opportunities to bring up your grade, to earn high school credit, to graduate and get out of this place, unless you want to come back because you loved it so much, like me. To really just kind of finish strong. Okay, so this timer is going to be included now, as we have 45 days, friends. That's not a lot. That's not counting school days, I don't think. No way. It's October, at the end of October, December 12th. Yeah, December 12th. That's not even counting school days. That's okay because it's open on the weekends. All right, we're going to get in. I'll talk more about this later, but please remember, that's why I kind of put these in our grade book. That's why I link directly to the quiz help video, directly to the points help video, or notes on things like unit tests. Please reach out to me for support on unit tests and TGAs. That's where some of the great learning does. And that's, of course, always my goal, not just for you to pass, but for you to learn. So when you leave high school, you may not remember what grade you got in algebra or what grade you got on the Unit 5 quiz 509, but you'll remember some of these great, cool concepts like clever names for one, properties of identity, cancel culture in a good way. All right, here we go. 509. Boop. I try to link it everywhere too, by the way. Just link it. Just try it. Oh, man. Let's see how we did so far. Ooh, 141 of my students have already taken it, and back in our Algebra 2 class. That is beautiful. What a beautiful, that's just great. So again, we talked about being able to use computer algebra systems in order to help us solve our complex equations. I think that's wonderful. One of the cool things I found was you have to be very careful how you enter the equation or expression. You have to know how to use the technology, and then they might spit out an answer that's in a different form than the options you have. So you have to know how to simplify, rearrange the expression or the answer to get the one you're looking for. So I'm very excited, and if that's part of the reason, excellent. It's part of our standards in Algebra 2. We're moving on. You've got to learn this technology. Don't forget to understand the math. Think about it. Follow the steps. Try it on paper. Check your work on a calculator. It's best practice. Let's get into our test. If you're in the reds and yellows, you are still trying. Do not give up. If you're worried about failing, watch these videos, try those retakes, but most importantly, reach out to me, okay? Work with me. I will work with you. What is the solution to the equation? Okay, so there's lots of different ways to solve this, and you can have some fun with it, but the most straightforward way is something we call cross multiplication. We use this idea of cross multiplication, cross canceling, and I'm going to show you what it is. It's just a shortcut of these steps. I want to solve for x. So all of the same strategies and steps that I took in Algebra 1, maybe in 8th grade, definitely in 6th grade because I went through some of it with my students, is trying to get x by itself. So over here, I just see there's a 3 down there. I want to multiply by 3. But what you do to one side, you got to do to the other side. So I'm going to multiply by 3. Okay? So this whole thing is now going to become, this will go away. This will then become 3 times, I'm going to leave it in parentheses. I'm not going to distribute it. parentheses, x plus 2 over 2 equal to 5x. Well, I still don't really like fractions, so I'm going to multiply both sides by 2. So this whole thing will become 2 times 3x plus 7 over 2, and this will become 5x times 2. So then these actually cancel, because that's the point. That's why I did it. I don't want them down there. This will become 3 times x. Actually, I will distribute at this point. So now I'm going to distribute. Okay, that's going to be 3x plus 21 is equal to 10x. Okay, not done. Now this should be very, very, very familiar. You should be seeing these, have been seeing stuff like this since at least 7th grade. Okay? If you haven't, that's all right. I would like to know why. Maybe some gaps. COVID was a few years ago. That's totally normal. This is an algebraic expression. It has a variable, it has terms, it has factors. All of that's very important as we communicate with each other. Combining like terms, isolating the variable are all steps that we need to be solid at. And if we're not, that's okay. Again, just let me know. I want to get the variable to one side of the equal sign. Why? That's a good question. So anyway, this plus 3x minus 3x, the whole point is to get rid of it from that side and bring it over to that side. And 10x, if I have 10 x's and I take away 3 x's, I'm left with 7 x's. 21 equal to 7, x equals 3. How did I do that? Well, several ways. Number one way is multiplication. I've shared with you I prefer it. So 7 times some number equals 21. I got my times tables memorized, right? I could win it around the world if we played a flashcard game. Maybe. 7 times 3 is 21. So I know that x has to equal 3. If you didn't know that, or say it was a more complicated number like a decimal, which is more likely to happen as you get into higher levels of math, you simply divide both sides by the coefficient of the variable, because division undoes multiplication, and that says 7 times x, so I need to get rid of it. And 21 divided by 7 is 3. And the equal sign works both ways, so it doesn't matter if it says 3 is equal to x or x is equal to 3. Those are the same. Let's go see. Type it in the box. Oh, the suspense is killing me. Woo! Strategy is the same. I will do it a different way on the next one. I'm just going to do cross multiplication. Oh, there you guys go. Okay. This now, those had constant terms for their denominator, meaning the constant number was on the bottom. Cross multiplication would work the same no matter if you have an expression or just a number. Okay? What I simply do is I do exactly what it sounds like. So I'm going to rewrite this by cross multiplying. I will now have 9 times x plus 10 on one side. This is a great strategy to solve algebraic expressions. And then I will have 12 times negative 3x on the other side. Again, it's exactly the same concept as multiplying both sides by the denominator to get rid of that fraction. What ends up happening is on the one side, they cancel, right? They become 1, and they stay on the other side, and vice versa. So that's why cross multiplication works. Now we distribute 9x plus 90 is equal to negative 36x. Okay, what do you want to do here? Is this right? Yeah, it's got to be. Okay, check my work. Help me out. Do you prefer positive? It won't matter. So I'm going to, do you want to subtract 9 or add 36, bring the 90 over? There's lots of different options here. I'm trying to get x by itself. I'm trying to isolate the variable. So I could add 36. Let's do that so you can just see. I had a great question in class. A student did it in a different way. And the other said, why did you do that? Why didn't you just do this? I was like, well, that's what their brain saw, and that's okay. Right? If I see a negative, I used to do this more often. So, oh, this is fine. Look at this. That becomes positive 45 plus 90 is equal to 0. I'm going to subtract 90 now. Hopefully you see that. Even if it equals 0, that's all right. That's allowed. We are left with the 45x on the one side equal to negative 90 on this side. Now we divide by 45. See what I mean about different numbers? I mean, I know x equals 2, but again, it's practice with number sense. I'm a math teacher, so you're like, oh, you're a math teacher. Yes, that's true, but also I enjoy thinking about numbers. It's calming, satisfying, consistent. So, and if you get stuck or frustrated, that's okay. 90, negative 90 divided by 45 should be negative 2. We can check it though. That's all right. Let's demonstrate that. Negative 90 divided by 45, yay, negative 2. Notice if you have a calculator like this, some of them you have to use the actual negative sign, not the subtraction symbol. If ever you want tutoring on your calculator or an online calculator, also reach out to me. It's a very important skill, especially if you intend to pursue the math and sciences in college. You will use your calculator. Typically, those teachers will help you as well. However, it's very important to have a good knowledge of the technology. Okay, let's see if we were right. Negative 2. Negative 2! Woohoo! If we got it wrong, it's all right. As long as I didn't erase the board, I could go back and check my work. And you guys have been with me when I get it wrong and we go back and check our work, my work. I don't want to blame you ever if I make a mistake because it's not you. Okay, so we are on to this problem. There's so many ways to think about it, actually. There's quite a few ways to think about it. But in this case, I'm going to do this one with a common denominator for all of them. So what I mean is I'm going to multiply each term in this equation by the common denominator for all of them. I'll go through the steps so you could kind of see what's happening here. Okay? I see a z. I want to get rid of that z. So if I multiply this whole thing by z and this whole thing by z, each term, and this side by z, aha. Here, let me undo this actually. Let me write the parentheses so you see what's happening. I'm going to multiply this side by z and this side by z. So that's holding to properties of equality, right? What I do to one side, as long as I do it to the other, I'm keeping it balanced. I'm keeping it equal. So I will have over here z, and I'll just put it in the numerator, times 2z plus 6 all over z plus 2 is equal to 3 times z, right? I'm distributing it, minus z over z. That's nice. I'm going to leave it over z for right now. You're like, that's 1. It is 1. But I'm going to leave it as z over z for right now, just to show you this strategy. Okay? You're like, but didn't you want to get rid of the denominator? Yes. But I just want to show you where it goes. Okay. We can make it 1, actually. We'll make it 1 next. I still have, we'll make it 1 right now. We'll make it 1. It's okay. We want to get rid of it. That's the whole point. So might as well just get rid of it. Z divided by z is 1. So there, we're done. Now I'm going to multiply both sides. I'm going to multiply this side. I'm using a bracket. Doesn't matter. It still is a group. By z plus 2. I'm going to multiply this whole thing by z plus 2. Brackets act as parentheses, like parentheses. Cool. So what I see over here is that this z plus 2 is going to cancel, divide out, become 1. That's why we chose z plus 2. But over here, I need to distribute. I end up with 3z minus 1 times z plus 2. Okay? I would like a different color at this point. How about a pretty green? And I would like you to be just a tiny, tiny smidge larger. Okay. So now we have on the left-hand side, we're left with z times 2z plus 6. I guess I could have distributed it. Let's distribute this, right? I'm left with 2z squared plus 6z is equal to, let's FOIL this because I have to multiply it. I haven't done it yet. 3z squared minus z plus 6z minus 2. That's exciting. We're done. We're done. Who cares? Let's just stop. Let's subtract 2z from both sides. I'm going to bring it all over to one side. That's what I'm going to do next. I'm just going to continue solving for z. 2z squared minus z squared. We're left with 6z equal to 3z squared minus 2z, just regular z squared, minus z. Oops. Hey. Oh, I got rid of it. Let's change colors again. 6z is left on this side is equal to z squared, because I subtracted from both sides. I'm going to combine these like terms, which I forgot to do, which is fine as long as you have it written out. 2. Now, we're going to subtract 6z and set it equal to 0. Anybody see why? 5z minus 6z minus z minus 2. We're not done. But what do you notice? I talked about it in class. The examples we had in class, and I don't know why I didn't notice this, the squared terms removed themselves, meaning when we tried to solve for z to get all of our variables on one side of the equal sign, we had a z squared minus a z squared, so it went away. So we were left with just simply z to solve. This, however, is not the case. We have a quadratic equation, which means we either need to factor to find some values of z or use the quadratic formula. I'm going to use the quadratic formula. I've talked about factoring quite a bit, so I want to take this opportunity to use the quadratic formula. The quadratic formula, you have to have your quadratic equation in this form, set it equal to 0. A represents the coefficient of your squared term. B is the coefficient of your linear term, the just regular x or regular z. C is your constant term. The formula is the opposite of b. So in this case, if b is -1, it's just 1 plus or minus the square root of b squared, which is -1 squared, so I'll just go ahead and write it, minus 4 times a, which is 1, times c, which is -2. Remember to take the negatives with it, take the signs with it, all over 2 times a, which is just 2, because a is 1. Have that written down, practice it. It will still help you find a real number. All right, so this is going to simplify to 1 plus or minus the square root of, this becomes 1 minus 4 times -2, positive 8. Oh, cool. See, inside of here will become the square root of 9. That's lovely. Don't you think that's lovely? This isn't our final answer, though, because we can actually take the square root of 9 and add and subtract it from 1. So we end up with 1 plus 3 over 2, which equals 2, right? 4. And we end up with 1 minus 3 over 2, which is equal to -1. Oops, equal, not a comma. All right? So using the quadratic formula, we saw that our solutions for z are going to be 2 and z equal to -1. Those are our two possible solutions. Why did I say possible? If this was just a normal quadratic equation, those are our solutions. We're good to go. Those are our solutions. Those are our roots. Those are where the graph crosses the z-axis in this case. okay? But we have rational equations, so we can't, oh, it's both of them, but let me show you why. Did we get them, like -1 and 2? Let me see. Yeah, see, -1 and 2. Very good. Let me get rid of this mess. Hopefully you're following along. Why did I say possible solutions? They told us already some of the domain restrictions. Z can't equal 0 or -2. So that's wonderful. But whenever you don't have this information, you'd have to check. If Z equals -1, at any time, does the denominator become 0? No and no. So we're good. What about if Z equals +2? Nope. So they're both valid solutions, not extraneous. So the solution set for this equation is Z equal to -1 or Z equal to 2. That was fun. What question 3? Wow. Okay, let's keep going. Now let's try it a different way. That was a way of finding the least common denominator and multiplying each term by it. Instead of just doing it across the board, I did it one at a time. But that's the neat thing about math. You can do things in different ways that make sense for you. So break it down to its smallest possible sense-making start and start there. And then think, what can I do next that is allowed and true? And see. Okay, we've affectionately named this the Amara method because in class she had brought up the need to put this, or her desire to just make this a fraction so she could cross multiply. Great job. That's great logic. That's what makes sense to you, so do it. What skills do we need here? Well, just looking at 6 over m plus 2 implies that I need a common denominator for 2. Well, m, I need it to be over m, but I can't just magically place it over m. I have to multiply it by a clever name for 1 to get it to be a common denominator. M over m is 1. So this would become 2m over m. And then we could combine it. Oops. Can't do that. Have to have that m. Now we can combine them because they have a common denominator. And when you have a common denominator, you merely add the numerators. It's still equal to this m plus 3 over m minus 1. We can now use our cross multiplication. We will get 6 plus 2m parentheses times m minus 1 is equal to m times m plus 3. Okay, cool. Now we FOIL or distribute whatever properties of math we need to use to keep going till we isolate that m. We need m by itself. So let's see, we get 6m. Oh, look, it's kind of out of order. It's all right. Plus 2m squared. It doesn't matter. Minus 2m minus 6. And on this side, we're just going to distribute. So we'll get m squared plus 3m, and we'll call it a day. Cool. Now we're still not done. Our squared parts don't come out, so we have to use the quadratic formula again. I'm going to do this in one step. Minus m squared minus 3m. I hope you're okay with this. I want this side to equal 0, right? That's my goal. Those will. But now I'm going to line it up. Oh, I should have combined them. That's okay. Minus m squared. Notice I found the like term. Same variable, same exponent. Minus 3m. So let's go ahead and just do it right here. I'll combine these two m's in a second. Okay, so I'm left with 6m. Don't worry, we'll combine it with this other m over here. 2m squared minus m squared, so I'm left with just a plus m squared. Negative 2m minus 3m, I have now 5. Negative 5m minus 6. It's set equal to 0, so that's good. Now I just need to get it in standard form, meaning the m squared term, then the m, and then the constant term, so I can identify the correct a, b, and c coefficients to use the quadratic formula. Again, if you like factoring or you want to graph it, You could do that too. You could even graph this by itself and then graph this by itself. See where they cross, click on it, boom. If they cross twice, click on both of those. Anyway, we'll look at that in a second. We will have m squared plus m minus 6 equal to 0. I'm going to use the quadratic formula again. I have to change the color. Okay. The quadratic formula is, again, the opposite of b, which in this case is 1. It becomes -1 plus or minus the square root of b squared, which is just 1 squared, which stays 1, minus 4 times a, which is 1, times c, which is -6. So I'm going to go ahead and write that -6 right there. All over 2a, which is just 2 because a is 1. This is a, b, and this -6 is c. Now I need to simplify, solve, evaluate, however you want to think of it. I'll have -1 plus or minus. We've got 1 minus 4 times 1 plus 24. Lovely. A nice, lovely square root, right? All over 2. We're not done because we can actually take the square root of 25. It's a nice number. It's 5. So we're going to get our two answers. We'll get -1 plus 5 over 2, which that becomes 4. This just becomes +2. And we'll get -5 minus 5 over 2. That becomes -6 divided by 2, which is -3. So possible solution sets are m equals 2 and m equals -3, or just one or the other. Let's go see. We have to check them because we have to make sure the denominator of a fraction doesn't equal 0, because that's division by 0 and that's undefined. Okay, 2 and -3, just remember that. We're fine, right? That doesn't make it 0 and that doesn't make it 0, so we're good to go. And they tell you what the domain is, see? So as long as your answer isn't in the restricted domain, you're fine. They're both right. Woo, fun. Let's see if the next one is, and we'll graph it. Oh, we don't need to graph it. We need to find the extraneous solutions. That's okay. Let's do that. Okay, first, before we find the extraneous solution, x equals 5 or x equals -1. Over here, if we see 5 creates division by 0. Do you see it? Here's our solution, x equals 5 or x equals -1. 5 creates a division by 0 in this expression. So for this one, you guys could just check it. What's going on? There we go. Check the different options here. Extraneous, 0, there are no extraneous, but they give you great hints in this actual problem. Let's graph this to see what's happening, okay? So I want to graph Desmos, graphing calculator, 1 over x minus 4. Okay, is equal to, so that's this side. Look, I'm doing one side of the equation because I want it to be equal to this other mess. Oh boy. And I want to see what happens. I can't just set it equal, right? It won't quite work. But when we're trying to solve equalities, if you set the graphs equal to, or if you graph one and graph the other, they're equal when they touch. If and when they touch and cross. Let's go do this. So now we have, I'm going to write it down because I won't forget. I will forget. X minus 5 minus 6 over x squared minus 9x plus 20. Boom. All right. Probably wrote it wrong. X plus 1 divided by x minus 5. Notice how you have to I have to learn how to type this sometimes, and that's okay. I know how to type it. You need to practice. I've made videos. If you don't know, let me know. Again, calculator use is an important skill. Oh boy, look at all these. Okay. Here we go. That looks right. So now, if we're correct, the only solution we'll have is at x equals -1. There'll be nothing at x equals -5, which is another way of finding an extraneous solution, and we'll talk about it here in a second. Okay. We don't care about that. We don't care about the x-intercept of the graphs. We care about when they intersect, when red meets blue. Indeed, at x, see, this is the x is equal, the x coordinates first, to -1, which is one of our solutions. Let's see it at 5. Let's go look at x at 5. Let me move my face. Ooh. What is happening here? Hold on. I'm going to do x equal to 5. Huh. So there's x equal to 5. Well, there's some graphs, they cross it, because some of them it's okay. Let's look at that green line. Look at that. That's pretty cool. Let's take a look at this side. Look how it looks like they get really close, but they don't. There's no interception. Let's get closer maybe. Oh, look, see how they look like they're touching, but they're not. Okay, and then there goes the curves. Here's where they equal each other, right there at -1. So what is going on at x equals 5? This is fascinating. Oh, we gotta stay close. Looks like they're gonna... So x equals 5 is an extraneous solution. It causes division by 0, which again causes this phenomena where typically one end, there's some x squared, 1 over x squared, they think it converges to infinity. It doesn't, okay, diverges, but we can agree that it goes to positive infinity, I think, if I remember correctly. But yeah, look how the one side of the graphs go somewhere, the other side of the graphs go somewhere. So it's not possible. What happens at x equals 5 is we don't have any number that they can agree on. So that's why division by 0 is undefined, because we can't define what value it's going to equal. So as it gets closer and closer and closer to division by 0, they go off to infinity. Sometimes both to positive infinity, sometimes opposite directions. And then that opens up interesting math later on as we start to think about limits. But okay, thanks for watching. That's it. This is what happens, but you could always graph all of those other equations one at a time, one side of the equality, the other side of the equality, and then try to find where they meet, where they cross, not where the x-axis or anything, but when the two graphs meet. That's when they equal each other. Thanks for watching.